So good morning students. So in the last class, in the previous video, we have discussed the resolution of vectors and we are seeing the problems based on the result. So next we are going to solve the problem example 8.10. Show that the vectors 5i cap plus 6j cap plus 7k cap comma 7i cap minus 8j cap plus 9k cap comma 3i cap plus 20j cap plus 5k cap are coplanar. We have to show that the given three vectors are coplanar. This problem is very important 5-mark question as far as your examination concerned. Okay. So how to show that the given three vectors are coplanar means the concept is if one vector can be written as a linear combination of other two vectors, then we can say that the given vectors are coplanar. For that we are having a procedure. So I am going to state the procedure and I am going to solve the problem based upon that procedure. You have to remember this and you have to proceed in this way only to show that the given vectors are coplanar. Okay. First thing what you have to do is you have to name the given vectors. Okay. Let us take that the first vector as A vector. Let A vector is equal to 5i cap plus 6j cap plus 7k cap. And you have to take the second vector as B vector. What is the second vector? 7i cap minus 8j cap plus 9k cap. Then the third vector as what is that? 3i cap plus 20j cap plus 5k cap. Okay. So now we are going to write any one of the vector as the linear combination of other two vectors. So let me write that. Let A vector is equal to some L into B vector plus M into C vector, where L and M are the scalars. Okay, where L and M are the scalars. Okay. Next thing what you have to do is you have to substitute the vectors and you have to check whether the linear combination of vectors is correct or not. That is the procedure. Okay. First let me substitute the vectors. What is A vector? We have taken 5i cap, then plus 6j cap plus 7k cap, which is equal to L. That is a constant. So L into B vector. What is B vector? 7i cap minus 8j cap plus 9k cap plus M into, there is no space, so I am writing here M into C vector. What is C vector? 3i cap, then plus 20j cap, then plus 5k cap. Okay. So this is the linear combination of vector. We have to check whether it is correct or not. Okay. How to check means you have to equate the components of I, J and K. Okay. So next procedure what we are going to do is we are going to equate the components. We have to equate the components. Okay. Components means first you have to equate the I cap components. For this I vector components, that is here 7 into L. When you are taking this, what you will have? 7 into L. 7 into L is 7L. Here M into 3 is 3M. So we are having in the right hand side 7L plus 3M. We are equating the I components, J components and the K components. Okay, you have to consider only I component for writing the first equation, J for writing the second equation and K for the third equation in right side as well as in the left side. Okay, in the right side what you are, sorry, in the left side what you are having 5. Okay, so 7L plus 3M equal to 5. So this is equation number 1. Next I am going to equate J cap. J cap means this L is multiplied with this number. So 8 into L. Here you are having minus. So minus 8L. Okay. So minus 8L. Next, when you come here, this m into 20. 20 into m is nothing but plus 20m. We just go back to the left hand side. What is the j component here? 6. Okay, which is equal to 6. This is equation number 2. Similarly, we have to equate the k components. K components means this L is multiplied with 9k cap. So 9 into L. So 9L plus, here you are having 5. 5 into M is nothing but 5M, which is equal to, here the k component is 7. Okay, so which is equal to 7. So you are having totally 3 equations. First, you have to solve only the first 2 equations and find the value of L and M, and you have to substitute the values of L and M in the third equation. If the third equation is satisfied, then we can say that the way you have written the linear combination is correct. If the third equation is not satisfied, so we cannot be able to write the vectors in the linear combination of other two. Okay, so first you have to solve only 1 and 2. Now I am going to solve the equations 1 and 2. So listen here. Now when you multiply the first equation with 8 and the second equation with 7, so that the L will get cancelled. Okay, so what I am going to do is, first equation is multiplied with 8. 8 means what you will have? 8 sevens are 56 L plus 8 threes are 24M, which is equal to 8 5 is 40. Okay, and the second equation is multiplied by 7. 7 8s are 56. So minus 56L, then plus 140M, which is equal to 7 6 or 42. Okay, now I am going to add these two things. When you are adding this L will get cancelled, so that you will have 164M, which is equal to 82. Okay, which implies that the value of M is equal to 82 divided by 164. So M equal to 1 by 2. So the value of M equal to 1 by 2. Okay. Next, we are going to substitute the value of M either in the first equation or in the second equation. Whichever is convenient for you, you can substitute in that. Okay. When I substitute here, it will be convenient for me. So I am going to substitute the value of M in equation number 2. Okay, when you are substituting in equation number 2 means equation number 2 implies that minus 8L plus 20 into M. What is the value of M? Which is nothing but 1 by 2. Okay, next step, which is equal to 6. When you cancel this one, you will get this as 10. So what you will have, which implies that minus 8L, which is equal to, when this 10 goes to the other side, it will become minus 10. Okay, 6 minus 10 is nothing but minus 4. Okay, the value of L is equal to, this minus and minus will get cancelled, so you will get 4 by 8. So L is equal to 1 by 2. Okay, so we have found out the value of L and M using only the first and the second equation. The next procedure is, you have to verify. How you have to verify means, you have to substitute the value of L and M in the third equation. You have to substitute the value of L and M in the third equation. If the third equation is satisfied, then we have written one vector as a linear combination of other vectors. Okay, let me check that one. So now we are going to do the verification. Verification means you have to substitute in the third equation. Take the left hand side of the third equation. Left hand side of the third equation means 9L plus 5M, which is equal to 9 into L. L is nothing but 1 by 2 plus 5 into M is also 1 by 2. When you take the common LCM as 2, So you have to add this. When you are adding this, 9 plus 5 is 14. So 9L plus 5M is equal to 7. So the equation is satisfied. The third equation is satisfied. The third equation is satisfied. If the third equation is satisfied, we can say that one vector is a linear combination. One vector is a linear combination of other two vectors. So we have written one vector is a linear combination of other two vectors. Final conclusion, therefore the given vectors are coplanar. Okay, so this is the procedure. This is very, very important and easy problem to you. So what the problem says is you have to show the given three vectors are coplanar. The concept of coplanar is if one vector can be written as a linear combination of other two vectors, then our proof is over. How to check whether the linear combination means? This is the procedure. For all the problems you have to follow this procedure.